This question is about solubility. A mixture of copper 1 and silver ions are together in a solution. The concentration of the copper ion is 0.0045 molar, and the concentration of the silver ion is 0.00014 molar. Okay, so that's not a very high concentration, right? They ask us to calculate the minimum concentration of the chloride ion. So chloride ion will be like Cl minus, needed to precipitate each metal ion. Okay, so in order to solve this question, we need to know about the KSP. So KSP is actually the solubility product constant, okay, of a salt. And basically, we can see how can we identify this one. It basically will define like this one. Like if we got the salt CuCl, right, dissociate in a solution in the solvent water solvent, then we got this one as plus and this one as a minus, right? So then the KSP is defined based on if this is the cation, if it's the anion, then we got this is the concentration of the cation to the power of the coefficient before. This is just a 1 and it's also a 1, okay? So we got this one is the anion concentration and then to the power of 1, 2. But if you got some other example, like if you got another kind of salt, let's just say that A, B2 for example, and A is the cation, that should be 2 plus, right? Okay. And then B will be just 1 minus, but there are 2 of them. Then the KSP will be the concentration of the cation to the power of the coefficient before. And also this one will be the concentration of the anion, but this should be like to the power of 2, the coefficient before. And this coefficient is based on the stoichiometry, based on the equilibrium, after we have got the reaction in equilibrium. Sounds good? Okay, so basically this is the product as well as the Q, but if we got the Q less than the KSP, this constant, then will not precipitate yet. But once this product reach a value that higher than the KSP, then it will precipitate. Okay, let me write down here. If you got the Q, okay, by that, my bad, just like the very general one, okay. If it's just like instead of like have it like here, this is the N, okay, then this will be like M, then it should be like M, it should be like N, right? Then the power here should be M, and the power here should be N. I just want to show you the most general case, okay? Then you got the product Q equals to M, and then concentration. I mean A is the cation, okay? This is the cation A. And this should be the anion B, okay, to the N. And A and B should have some charge as well, right? Yeah. So basically, you can have the Q here. Well, if it's less than the KSP, so it's no precipitation yet. No precipitation yet, okay? But if this one greater than the KSP, then yes, there will be precipitate. Okay, so here, just look up the data. Okay, this is a table of the data. Just chase it back to see here. You see, this is a copper 1 chloride, and this is the KSP for that. Okay, and this is the silver 1 chloride, and this is the KSP for it. Okay, so now just I just have these value back here. Okay, so we can see that the minimum concentration of chloride needed we can find it by having this product divided by the concentration provided from the problem statement here. So this is at least the concentration that we need, the chloride concentration, in order to precipitate the copper ion in the solution. And then we do the same thing for the silver chloride. Then this is the concentration of the chloride needed. So we can see that because there's a difference in the KSP for these two substances. Oh, I'm missing an AG here. Okay, my bad. This is silver. Okay, so then we can see, okay, concentration for this one is like around power to the -5. This one around -6. So it means that we don't need much concentration of the chloride as we need for to precipitate the copper. Okay, makes sense? So that's for the first question. The second question asks us to indicate the range of concentration over which one of the two ions can selectively be precipitated and which ion will be precipitated in that concentration range. So basically here, we just need to see between the two ions, copper and the silver, right? We have like 5 copper zones here and we have like 4 silver zones here, and we actually just have like 4 of them, right? 4 of them here that have the same anion, like bromide, chloride, Cn minus, and then the iodide. So then we just basically follow the math like in the A question. We need to find the concentration of the anion at least needed to precipitate, right? By having the KSP divided by the concentration of the cation itself. So for the copper, this is the concentration, and for the silver, this is the concentration. It's just from the problem statement. Then just by calculation, this is all the concentration of the bromide, of the chloride ion, of the Cn ion, of the iodide ion. Okay, so now if we compare, you can see here the bromide ion needed to precipitate the copper is this much, okay, to the power of the 10 to the -6, and the bromide ion that needed to precipitate the silver ion is like to the like -10. We see this one is like 1000 less than this one. So what does it mean? It means that if we got the concentration of the bromide in that range, like just before reaching this value, okay, then only the silver ion will be precipitated, right? This is not much. This is not enough to precipitate the copper. So only the silver will be precipitated, and that's why this is a selective precipitation. Make sense? Okay, so then if you do the same for all the other 3 ions here, for the chloride, this is like 10 to the -5, and then this one is like to the -6. So again, silver will be selective precipitated before the copper. Then for the Cn minus anion, we see this is like 10 to the -18, but this one is actually just 10 to the -13. So in this case, the copper ion will get precipitated first, right? Because it's just require a much lower concentration of this anion, okay? And then lastly, for the iodide, we got silver here, 10 to the -13 molar that required. For this one is at 10 to the -10. So we can see that for this one also, the silver will be selective precipitated first. Okay, so that's the point. Okay, let me know if you have question. Thank you. Good luck.